So good morning. We were just looking at in the last period, you would be able to see this screen which is shared here. What is the necessary dynamic understanding of your tire during braking? That's what we have seen in the last period in order to ensure preventing locking of wheels. So this requirement of your free body diagram can be achieved through an advanced control, electronic feedback control system, what is employed in all the vehicles mandatorily today is what is called an ABS, anti-lock brake system. So we are going to look at that ABS in this period, right? Its working principle, how can we connect that with this free body diagram that we have learned in the last period, right? So this is essentially what we have seen in the last period. So let's go further. If you look at the ABS, you need to understand what are the basic system. What is this ABS system? What are the elements that are involved? So there are 5 important elements in that. So one is what, the sensor. It has got a sensor. So this sensor is normally a sensor which measures the rotational velocity of your vehicle. Right? Rotational velocity of your vehicle, omega, how can it be measured? By means of some tooth wheels and some pickup. So you would have a laser that is going through this tooth wheel rotation, and you will have some pulses per second, say some 50 to 90 pulse per second or 90 to 120 pulse per second. There are different range of sensors. That's called the pickup sensors, so that you would always able to monitor the rotational speed of the wheel. That's what is the sensor work. So what does the sensor does? The sensor picks the speed, and that is being sent to this unit 2, what is called a control unit or electronic control unit. Electronic control unit, ECU. So this electronic control unit essentially should have the different task for it. What is the different task? Whatever the speed that has been sent from the sensor be held in the memory of this control unit, and it will process that. There will be a processing module in this control unit, so that it would take this speed, and then it will hold, and it will process, mean it will have some threshold values, and it will compare, and it has to take a decision to send an information to this modulator. Right? So the control unit will have a signal processing module, a module for predicting whether the wheels are about to lock. That would be a module present in this control unit. A module for determining whether the danger of locking of the tire is averted. So it means what? When you are braking, the wheels are going to lock is first to what is to be processed and to be understood. If it is not locked, it is prevented, and then it is safe. That also to be understood. So point of locking to be processed, there would be a module for that. And then there is another module in ECU that see that the safe locking is averted. The locking of wheels are prevented. That is also to be understood. If it is prevented, then accordingly it has to give an instruction. Then there is a module for generating a command signal. It will give a command signal for activating the pressure modulator accordingly. So if it is about to lock, I have to reduce TB. I have to reduce TB. We have just now seen. So TB comes from brake system. This is from brake system. So what do you mean by brake system now? Look at here, wheel cylinder and master cylinder. So there is a master cylinder which is connected to this pedal. So as you pedal, press the pedal, brake pedal, the pressure from the master cylinder that goes through the modulator. So in this line, the modulator would decide what is that pressure to be employed on the cylinder pressure, wheel cylinder pressure. So wheel cylinder pressure is finally going to provide this TB. The TB is provided by wheel cylinder pressure. So the TB, the brake system torque, is dictated by the pressure that is given to the wheel cylinder from the modulator. So what do you mean by the task of the modulator? The modulator can vary that pressure in this line, whatever is there, from 0 to or some minimum value to, not 0, from minimum value to some within a range of value of air pressure, right? So that's what is possible for the modulator. So it can increase the brake pressure in the wheel cylinder, or it can decrease the brake pressure in the wheel cylinder. If it is increasing that, that means TB is increasing. If it is decreasing, means that means TB is decreasing. So on the other hand, what's happening? I have this FBR. So FBR is coming from tire road interaction. That's why TT in this. So if I have the condition TB greater than FBR, then means what? It is about to get locked. So the module in the control unit would give an instruction that please reduce the pressure. So the pressure will be reduced. Then what will happen? Then TB will be less than FBR, and TB will be less than FBR. So when TB is less than FBR means the wheels are not locked, it is rotating. When it is rotating, what will happen? Why it is rotating? When TB minus FBR in the free body diagram that we have seen in the last period. So look at in this free body diagram. When TB is less than FBR, I get an angular acceleration. When I get an angular acceleration, what would happen? The omega value will be increasing, the speed will be increasing. So when speed increasing means the wheel is not locking, instead it is rolling. So these two conditions would be taken care by two modulator in this. So two modules in this control unit, so that would accordingly give. So if this condition comes, again it will instruct, oh, that is going, I have to reduce it, I have to stop it. So again it will give an instruction, then make this TB goes slightly than more than this. But it goes more than that, suddenly it will stop, but the wheel to be locked, then it will be flipping between these two. So your wheel has to decelerate so sharply, your wheel has to suddenly increase in acceleration also less. So it has to be in both the state. So this both the state is being achieved by this electronic control unit with their individual modules. So it will have one signal processing module. One module is to just make an assessment of is the wheels are about to lock or not. And another one is if the wheel locking is prevented or not. Wheel locking is prevented means this state. It's prevented. Once it is prevented, then again it will give a signal to the modulator so that now you can apply brake. When you apply brake, wheel is about to lock, then again it will give. So like that, it will be flipping between that. That instruction will be given to the modulator. A modulator would be very honest person there. So you would exactly follow what is that instruction coming from ECU. Accordingly, you will modulate this pressure so that the variation in the cylinder pressure in the wheel would make sure the braking event of the wheel. Why this is important? That's what we have seen. We have done a quantitative assessment in the previous lectures, seeing that the condition of the deceleration associated with the wheel, front wheel locking, or deceleration associated with the vehicle of the rear wheel lock before front wheel lock. So those conditions we have seen. So that should be same as what we have seen for road with that important assumption. NIP is constant there. When it is not so, what will happen? Every wheel, 4 wheels of your vehicle are having different road conditions, say different speeds. Why different speeds? When a turn, if you look at the outer wheel should be rotating faster than the inner wheel. That's a requirement. So in such scenarios, you see that the braking torque applied on the wheels are required to be will be varying. So it has to have an individual control or a collective control and so on. So you'll have different layouts of this ABS that's working on the employed on the vehicle. But what is essentially this ABS does is it makes your wheels to decelerate so quickly and accelerate so quickly, decelerate, accelerate, decelerate, accelerate, so that the speed of your wheel, linear speed of your wheel, V, is going to be some 3 to 5 kilometers per hour. From say 120 kilometers per hour, when you are driving your vehicle, you apply suddenly brake, the ABS will take care would bring in within few seconds, 3 to 4 seconds, also the speed from 120 kilometers per hour to some 3 to 5 kilometers per hour. So after your speed is brought to a very slow value, ABS function is not needed, right? At that time, automatically the activation of ABS would be stopped. So that is also would be taken care by this ECU. So there will be a minimum speed, and that speed is what is being sensed here by the sensor, that this 120 kilometers per hour is reduces to this corresponding omega value reduces here in the wheel. If it is felt by the ECU, read or signal processed in the ECU, then it would deactivate this ABS and you would ensure the safe braking. So these all are to say on words, it's easier, but you can look at some interesting videos to understand this further. So before that, let me just have some more elaborative study on this ABS. So let us look at what is a typical characteristic of an ABS of a heavy commercial vehicle. So in a heavy commercial vehicle, if you look at, there are 5 parameters that are very important that ABS is always controlling. One is tire skid. So that's there here, tire skid. Another one is vehicle speed, V, that's there here, right? Another one is 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 there. Brake pressure, importantly, PSI. See, this is brake pressure, P. Brake pressure. So that varies from 0 to 60 is what is, or 0 to 400 kPa is what is that brake pressure value of my wheel cylinder. But it is not 0. See, you can see that is maximum is 60 psi. So there will be a smaller value of some 15 to 20 psi. So there is a fluctuation of this pressure, brake pressure. So what do you mean by that? If the pressure falls down, that means it's acceleration. If the pressure picks up, that means it is deceleration. So that is happening simultaneously. So this pressure, and then R omega. So R omega is what is your wheel center linear velocity. So wheel center linear velocity is not constantly reducing. See, this V is what is vehicle speed, this envelope of this. And R omega is what is wheel center velocity. R omega dot is what is linear acceleration of the wheel center, AC. It's not AC. AC is given by, we have seen that it is FB by W by G. That's what is from the dynamics free body diagram. That's AC of the wheel center. And this is from that. And R omega dot is what is of the free rolling one. So this may not be always same. That is why skid principle comes. Like V is greater than R omega during braking, right, in the tire. That's why we have a definition of V minus R omega by V into 100%. What is defining IS? So when it is for the speed, this is the rate of change of the speed. So you would have AC and R omega dot analogous terms. So AC is coming from wheel center linear acceleration, and that is from this inertia force, the mass of the rotating wheel, as well as this FB. What is the normal, braking force that comes, which we have seen in the previous lecture, free body diagram of the force balance. Let me just show you that. So look at here. Look at here. So this one. So this is force balance. Sigma F is equal to MA. So both sides I will consider right side is positive. What would happen here? This is FB positive, and this side it's MAC, where AC is deceleration, linear deceleration. So this would be compared with the R omega dot. R omega dot again is what is free rolling linear acceleration, but there would be the skid phenomena. So this is all you should understand. So now let us go ahead with this and understand this characteristics. So you see that it's very interesting. You can see here anti-lock on off signal, on signal off signal. So if you see this one, it is on, off is for more time. So on for a fraction of second. So the ABS activation is very fraction of a second, whereas compared to that, off condition is more. That you can see. If this is a 1 second, it's not 1 second. See, look at this horizontal scale. It's 5 seconds. In 5 seconds, what has happened? The speed here, which is 15 meter per second, 15 meter per second is dropped to 0 seconds. So 5 seconds, this much reduction, deceleration is possible. So the slope of this curve is what is the cumulative deceleration, V, right? So here, for an understanding purpose, all these all these parameters, how they are, their events, variation in their events are represented in order to understand the characteristics of ABS. So look at here, you have skid value. Skid value 0, you can realize the braking force. So you have to have a skid happens to get to your FB. So FB is because of skid. Like tractive effort is because of slipping phenomena. If tire is not skidding, you cannot develop a braking force. So FB to develop, you require skid. That's what is from the graph that you see. So to define that only, we define a coefficient called the CB, where the CB is FB by normal W. So the CB value is what it is going to vary, something like this, right? That's what we have seen. So this is the operating range. So this is the corresponding skid IS value range. It has to be in this range. And that's what you can see here. The first, when it is activated, when the vehicle speed is at 15 meter per second, you see there is a skid developed. So maybe it is less than, it's around 20%. So when it is skid developed, what will happen? You will have your braking force that comes. When braking force that comes, you see that TB, applied torque, and braking force comparison will be there. So if TB minus FBR is positive, then it is deceleration. If it is negative, then it is acceleration. That's what, as per the diagram, free body diagram, I have drawn and explained to you, right? So you can see that when it is on, you see the skid, whatever is there is reduced. When skid is reduced, what do you mean by that? When skid is reduced, what do you mean by that? You would have your braking effort comes down here. So when braking effort comes down here, you would see that your omega dot is going to be falling so drastically. So omega dot R is what is the corresponding linear acceleration of the free rolling tire. So that's what is happening here. So the variation of omega dot R you could understand. So see here, it is increasing. So this line is what is acceleration. So when it is not on, when it is on, you have the skid reduces, right? And you see there is this is what is your acceleration, and this is what is your deceleration, sudden fall this side. So you can see here R omega is what is linear. So you can see R omega increases, then it is dropping. This is happening in one cycle. Like that, you would have in a second, it's not more drawn here. It is 15 to, for this diagram is not shown all 15 to 16 cycles per second. If it is so, then it should be so dense. So for an understanding purpose, you have got it like this. And also it is going to be 15 to 16 seconds when I have said it is 120 kilometers per hour, you are applying brake, that's fine. But here you see it is shown, this graph was taken only from 15 meter per second. So 15 meter per second equivalent to how much kilometers per hour? Multiply this by 3.6. So it is not for this, almost half the value of this. So if it would have been this speed, you would see this fluctuation in the brake pressure, or this fluctuation will be so closed. That's why you can see that the deviation, the fluctuation gradually increased with the longer time. So here it is closely packed. This interval, time interval is gradually increases. See here it's very much more. And it is no more peak further because it is achieved to this vehicle stopping. So the stopping is gradually happening because of this ABS function. So when ABS is on, you would see that the brake pressure is dropped. And then again the brake pressure is increases. So when brake pressure is dropping, what would happen? You would have TB less than less than FBR, right around. When brake pressure is dropping, that is wheel cylinder brake pressure is dropping, that means it is not going to apply braking. TB is greater than TB is less than FBR. When brake pressure is dropping, when it is dropping, TB is less than this. When TB is less than this, I would have in my omega dot expression, which is TB minus FBR by I, what we have derived in the last class, right? So I would have this value negative. So negative value here is referring to acceleration. That's why you would see that when it is dropping, the velocity is increases. When it is increasing brake pressure, velocity is dropping. So you would be able to compare this. So R omega increases when pressure is dropped. That is acceleration phase of your wheel. And R omega is decreases. That's because of omega decreases. R is constant. Omega decreases. Omega decreases is deceleration. At that time, you see brake pressure is increases. So when you apply brake pressure, you would be able to flip between these two conditions, what we have looked at in the free body diagram. You will be that the system would be flipped between these two conditions. Right? Yeah, I think you understood important working principle of your ABS connected with the free body diagram that you have drawn. Additionally, you have understood what is the necessary characteristics of this ABS. Everything is connected to the dynamics of your wheel. And then you see this ABS comes with the different layouts. So you can have here a number of channels and number of sensors. Right? What do you mean by channel? Channel refer that it is an independent control of number of independent control of your brake system. So if I have 4 channels, so there are 4 independent portion of my brake system control. That's the meaning of channel. Sensors means how many number of sensors employed. So there can be 4 sensors, means there are 4 wheels, there are 4 sensors, pickup sensors, and 4 channels. So I will have one for this, one for this, one for this, one for this. So there are 4 independent control of all the wheels. So why do you have such kind of layout? Because of operating scenario condition of your vehicle, the road surface condition. So you may have a slippery road suddenly on one side of the vehicle, whereas on the other side it is not so. So and so on. When you are taking a turn, you see that outer wheels are rotating, inner wheels are not rotating, or inner wheels are rotating, outer wheels are not rotating. So you would have difference in your FB on the road surface. What will happen during turning? You will have your roll of your vehicle on the outer side. So in the roll of your vehicle on the outer side, the normal on the load on the outer side is more than that of an inner side. So in such cases, the lateral force developed in the inner wheel is smaller than that of an outer wheel. So that would make the resultant lateral force reduction, and that is not preferred. That should be adequate for having your hold of directional control during cornering and so on. So this type of things are available that would ensure it. That's the thing. Similarly, you can have 3 channel and 3 sensors. So 3 channels means I would have an independent 2 wheels, front wheels, and 1 channel and 1 sensor combined looking at the speeds of the rear wheels. So 1 sensor which is put at the differential, so that it would take an average speed of both, and then accordingly it would act. So the ECU of your ABS would have the modules instruction to the modulator in order to work on the tire cylinder pressure from the master cylinder pressure during braking. Similarly, you see here 3 channel ABS with 4 sensors. So you can have 3 channel but 4 wheels here. So of course you can have an average value, or you can have here independent, but only one control. These two pressures are going to be controlled by this. But why then you can have 2 sensors, you may ask. That's where there are some scheme that comes, select low principle or select high principle. Select low, select low, or select high. So what do you mean by select low, select high? Select low means the lower speed of the wheel. Select means higher speed of the wheel. So in generally, select low is preferred, applied on a rear axle wheel, rear wheels. And this is on front wheels. Front wheels. You'll understand why now, right? So you see here with this, what are the actual, with the ABS, what are possible? You are able to have a steerability, stability, and braking distance. All are possible. So you can also see here, it's possible not only on a symmetrical road surface, also on an unsymmetrical road surface. So this kind of notation is for unsymmetrical road surface. So this all these 3 schemes can take care of all this importance of 3 required importance: steerability, stability, and braking distance. So these are the objective of ABS, right? That's possible. So now how that is working? This is working. That's what to see. Let's have, there are some threshold value. It would look at I omega r omega dot. R omega dot is what is an linear acceleration. So there is some recommended value 1.6 g, 1 to 1.6 g. So within this value, if it falls, there is prevention of locking. If r omega dot goes beyond 1.6 g, then you would have locking is about to happen. Then ABS would accordingly instruct. So this is one scheme. And then there are passenger car with the track hold circuit present in that, right? So what would happen? R omega dot, omega is what is measurable. See, the wheel center VC, wheel center speed is not easy to measure. Linear speed of your wheel center is not easy to measure. So what are easier quantities to measure? You can measure omega by pickup sensor. You can measure, you can get omega dot at what rate it changes. So by having this, I would be able to get this parameter because R is fixed. So that I would have my preferred value, which would be safer, is between 1 to 1.6 G of this value. Whenever it goes beyond this, that would take a call of your modulator to reduce the brake pressure, so that locking is prevented, right? So what would happen, the modulation would be such that it won't, it has to again act as increasing the pressure. So what would happen, it would wait for 5% of the speed reduction. So whatever the angular speed omega was there, whatever the angular speed omega was there, if that is from the previous value 5% reduced, then again it will compare with the linear acceleration r omega dot vehicle measured acceleration, that is coming from this is equal to fb by wg. So this value would be 0.5 g. So if it is less than 0.5 g and you have got this condition 5% reduced, then it would again say now you can decrease the braking torque. That means you can decrease the increase the braking torque. You can increase the braking torque. That means you can increase the wheel cylinder pressure, right? So 5% speed reduced, and it will compare with this value, which is 0.5 G. There will be a sensor for that. You can measure what is your vehicle deceleration at its CG location, mounting a sensor. So if this is achieved, then again it will give an instruction to increase the brake pressure. That means applying the brake. Again it will compare by applying the brake, what is happening to this. If the deceleration rate is more than this, then again, so that would be, that cycle would be repeated. That's one thing. What is this select low, select high? That let us understand. So select low is low speed. See, when you see the, though there are 4-channel 4 sensor here, they are independently controlled. The modulator get the instruction from ECU, smaller speed out of this rear wheel. If these are rear side and these are front side of the vehicle, because the braking pedal is in this direction. So you would see that the smaller of the speed would be taken as a measure. So that should not lock first. So if I take like that, smaller of the speed as my reference speed, and accordingly I would expect my ABS is working, then it would be preventing locking of rear wheel. If I take a higher speed of that, what would happen? The smaller one would lock. One wheel will lock, other wheel will not lock. So that is not preferred again. That is why smaller of the out of 2 wheels would be preferred always to ensure the directional stability. This is for stability. On the other hand, in case if I have on my rear select high option, that would make a wrong decision, right? Select high is preferred to compromise with this for the front wheels. So in the front wheel, whichever the wheel reference would be always taken as higher speed of the wheel. Why? Because I know lower speed is taken as safer, but that would unnecessarily increase the stopping distance. So I would take higher one here. So there is a compromise. So generally, the scheme of reading the speed of wheels of the front from the 2 sensors are with the high select high principle, the rear wheels with the select low principle, and that speed will be held in milliseconds, 140 milliseconds also in the sensor memory, and then it would compare with these threshold values, and no, I expect that is it going to be locking event happen or locking event prevented. Accordingly, the 2 statement, locking about to happen, locking is prevented, locking about to happen, locking prevented. So that means wheel is under acceleration, wheel is under deceleration, wheel is under acceleration, deceleration. So that would be the equivalent thing. So these all principles all are based on what is the free body diagram that you have looked at today's class, right? So with that, I would like to show you some few important videos, and that I would stop today's lecture. So that would be for another 5 to 6 minutes, and you'll listen to those videos, and then we will proceed ahead, right? So let me just share those videos, and then we will go. I hope you are able to hear, and in case while sharing there is a problem, let's sort out that. So let us first look at why do we require this ABS, right? Are you able to hear the video sound? No. So let me stop sharing this screen and then go to that video screen. Video file is here. Are you able to see this video file? Can anyone answer? Are you able to see this video file?
Yes, sir. Yes, sir.
Yeah. If I play, I think you should be able to hear this sound as well. In case you are not able to hear the audio, please let me know. Are you able to hear the audio also?
No, sir.
Just a minute. Then I have to do that. Just let me once again share. Just a minute. How do I do that? Yeah, I think now it would work. And
braking with AB.
yeah, are you able to hear now the audio as well?
Yes, sir.
Yes, from Bosch. The need to be mobile is rising. Traffic is growing ever heavier. Critical traffic scenarios are increasing. With unclear traffic situations,
Now I think you are able to hear both, right? Video as well as you are able to see video as well as able to hear, right? Please say yes or no.
Yes, sir.
Yes, sir.
suddenly occurring traffic jams, or obstacles. Sometimes only full braking can save the situation. When applying full brakes in critical situations, or when braking on slippery roadways, the wheels can lock. The vehicle can no longer react to the driver's steering because the locked wheels can no longer convey the optimum braking power and necessary turning force to the street. It hence becomes nearly impossible to evade an obstacle. ABS, the anti-lock braking system from Bosch, prevents locking of the wheels. ABS ensures that the vehicle remains steerable and stable while fully applying the brakes. The ABS control unit also continuously monitors all wheels by means of wheel speed sensors. Should the system recognize that a wheel is locked, ABS immediately intervenes and systematically regulates braking pressure. ABS can regulate each individual wheel within milliseconds. With the electronic anti-lock braking system, a sort of electronic intermittent braking, ABS achieves stability and steerability with the shortest possible braking distance. Let's have a look at the ABS benefits in practice. Full braking at 100 kilometers per hour. With ABS, the braking distance is significantly shorter and the vehicle remains stable. Full braking in a curve. Without ABS, should the wheels lock while applying full brakes along a curve, the vehicle can no longer be steered and slips out of the curve. With ABS, you have the vehicle under control and you can steer systematically. Full braking and swerving. Should the braking distance not suffice, the driver must swerve to evade the obstacle. Without ABS, the vehicle cannot respond to the driver's steering attempts. With ABS, your vehicle remains steerable and stable. A collision is thus avoidable. Full braking on different surfaces. Traction on lanes may vary due to volatile weather, dirt, and foliage. When fully applying brakes without ABS, the vehicle can quickly become unstable. With ABS, the vehicle remains stable, even in this situation, with an optimal braking distance. In everyday life, these abilities of ABS are vital. ABS prevents the locking of wheels when applying full brakes. It shortens your braking distance and ensures that the car remains steerable and stable. ABS is essential for your safety. Safe braking with ABS from Bosch. Bosch, invented for life.
So this is one of the nice video that is published from Bosch to understand this need of ABS and its importance, right? So I hope that you could have got whatever that I was trying to teach you this period, all could be witnessed through a real time viewing of scenario of this vehicle on different conditions. So you are able to see that ABS primarily is to prevent locking of wheels so that it is going to ensure good steerability and stability of your vehicle on any poor road condition, whether slippery road condition and so on. That's what we have witnessed from this video. I would share one more video of working principle of this ABS to understand in more detail, right? So if you have other lecture, you can proceed. Later on, you can see this end part of the lecture, right? So let me just share one more video that would be very interesting to again to see. Just it is for 2 minutes video, which is the working principle of ABS. Let me just share that as well. Where is that? To share, yeah. Share. This video essentially for
this section examines the anti-lock braking system. Applying brakes too hard or on a slippery surface can cause the wheels to lock. When wheels lock, steering control is lost and, in most cases, it produces longer stopping distances. The anti-lock braking system prevents wheels locking or skidding no matter how hard brakes are applied or how slippery the road surface. Steering stays under control and stopping distances are generally reduced. It consists of a brake pedal, a master cylinder, wheel speed sensors, the electronic control unit or ECU, and the hydraulic control unit, also called a hydraulic modulator. The wheel speed sensor consists of a notched or toothed rotor that rotates with each wheel and a pickup. As the wheel turns, a small voltage pulse is induced into the pickup and sent to the electronic control unit. When the brakes are applied, the wheel's speed of rotation changes. This sends a new signal to the ECU. If the control unit detects that a wheel might lock, it sends a signal to the hydraulic control unit. In a 3-channel system, the hydraulic control unit uses 3 solenoid valves to control brake pressure and prevent them locking. The valves are in series with the brake master cylinder and the brake circuits. One operates for each of the front wheels and one controls both rear wheels. At the start of a journey, the ABS automatically checks itself. Any failure in the system lights up a warning light in the dash panel.
So these are the 2 videos that I would like to share to you to understand this. There are many more videos available on YouTube. You can just watch. Not only for this, any of the vehicle dynamic scenarios that you want to understand, you can just do search in YouTube and you would get good videos. That would also help you to understand what we are learning in our dynamics course. So with that note, I would like to stop today's lecture, and this lecture ending an important module called an longitudinal dynamics aspect of your two-axle vehicle, particularly a passenger car. So in the next lecture on Wednesday, 9 o'clock, we will start with another module called the lateral dynamics of our course, right? So if you have any specific doubt, you can ask. Otherwise, we will end the meeting today. Any doubts? Anand Krishnan?
No, sir, no doubt.
Any doubt?
No, sir, no, sir.
Yeah. If there are no doubt, at the beginning of the lecture, I have seen there are only 33 students were present. I had given an important instruction that this week we are going to have your J component review 1. So what is that? You have worked further after your 0th review submission of your topic, and then basic idea of how do you proceed with your J component. So this review would not only make an assessment of what you have done, also would provide necessary instruction or suggestions. How can you further take your project to get some remarkable outcome out of learning this course. So with that note, let me stop recording of this video and then go ahead with today's